Hello everyone. Welcome to the project implementation of washing machine simulation using PICSIMLAB under the Embedded System Internship offered by Emertxe Information and Technologies. So, let's begin with the table of contents. First, we see introduction, thing, what is embedded system, microcontroller, design and board selection, tools used, project implementation, and conclusion. Introduction. A washing machine automates the process of cleaning clothes through a sequence of operations: washing, raising, and spinning. It operates using a components like a motor, water pump, heater, sensor, and control panel. mm, to manage the washing cycle. To ensure the efficiency, safety, and programmability, a microcontroller based embedded system is essential for real time control of motor and valves, monitoring sensors for door, water levels, user interface, and cycle management. This project implements the functions using the embedded C on the peak microcontroller. Here we use the peak 16F 877A, which demonstrating how the software and hardware work together in a real world applications. So here we have a question: why embedded systems in washing machines? So for these we see, for precision control, timers and interrupts allow accurate control of motor and valve operations. Customization, that is for multiple washing programs via the switching inputs and logic. Automation, it executes a washing sequence without user intervention. Cost effective, um, it is a minimal hardware with a usable controller logic. Safety, it monitors doors, water levels, and provides the alerts using the buzzer. During this internship, we have also learned about the embedded C basics. Embedded C is a set of language that extensions for the C programming language that supports embedded processors. It is used to write low level hardware interfacing code for microcontrollers. It also includes the key characteristics like efficiency for the minimal resource usage, portability that runs across the microcontrollers, real time execution, works with timer interrupts. In this project, embedded C is used to control the washing machine logic as switching between the programs, displaying status on the CLCD. Keywords in embedded C. Keywords are the reserved words in C that have special meaning and cannot use for the identifiers like variables, names, or function. So in C language or embedded C, we have 32 keywords. Data types that defines the types and size of the data that can be stored in variable. Choosing the correct type of important for the memory efficiency and proper operations in embedded system. Data types, there are three types of data types, that is primary data types, derived, and user defined. In primary, we see void, int, character, double, float. In derive, array, references, pointers. In user defined includes structure, union, and enumerations. Operators. In C, operators are the special symbols used to perform the operations on the variables and values. They are essential for creating expressions and implementing logic in embedded systems. So here we see the unary, binary, and ternary operators. Unary operators includes the unary operators. In binary, there are arithmetic operators, rational operators, logical operators, bitwise operators, and assignment operators. In ternary or ternary conditional operators. Conditional statements. Conditional statements are the decision making structures in C. They check if a certain condition is true or false and then execute a block of code accordingly. Common conditional statements in a C includes if else, if else if, nested if, the switch case, and the ternary operators. Here we see microcontroller. What is a microcontroller? Microcontroller is a compact integrated circuit which is designed to execute a specific task in embedded system. Unlike general purpose computers which can run multiple programs, microcontrollers are dedicated to performing one specific task repeatedly and efficiently. It combines processor, CPU, memory, RAM or ROM, and peripherals, that is input output timers communication on a single chip. There are key characteristics it having which is used in automation and control system programmed using the languages like embedded C microcontroller. And during for this project, we are using the PIC 16F877E microcontroller, which is a part of microchip's mid-range 8-bit family, which is ideal for the beginners due to its rich features set and is easy of use. It uses a modified hardware architecture, separate program or data memory basis, which enhancing a speed and efficiency. It having the key characteristics are 8-bit microcontroller from the microchip technology, operating frequency it is up to 20 millihertz, memory which having 14 KB flash memory, 368 bytes of RAM by 256 bits of EEPROM, input output ports. There are 33 programmable input output pins and 5 ports, that is port A to port E. Three timers it having communication mode is USART, I2C and SPI. Watchdog timer is here in circuit serial program. Here is the block diagram of our project in which we are using the four switches, that is switch 5 which is for used for the power on, switch 6 which is used for the pause or stop, switch 4 which is used for the navigations, switch 1 which is used for the door status, and which are connected to the microcontroller. Here there is a CLCD display which shows the washing machine status. Interrupt. An interrupt is a signal that pauses normal program flow to execute urgent task. After the interrupt service, normal execution resumes. Why use interrupts? It immediate the response to start or stop buttons, which accurates the timing with timer interrupts, efficient multitasking like wash, rinse, pin, control. Yeah, here external interrupt and timer interrupt. External interrupt which is used for the detecting start or stop button which responds immediately to the user input. Timer interrupt which is used for managing the watch cycle timing, generating accurate delays without blocking a code, which is triggered by the timer 0 overflow. Timers in peak 16F877A. In peak 16F877A has a three timers, timer 0 which is of 8-bit, timer 1 which is of 16-bit, and timer 2 which is of 8-bit with a built-in prescaler and postscaler, each serving a different timing and counting purposes. These timers can operate as timers which is counting internal clock pulses, or counters which is counting the external events, which is making them useful for the delays, event counting, and PWM generation. Each timer includes prescaler operations, allowing us to divide the input clock and adjust the timing interval, which is circular for the precise control in time-sensitive applications. CLCD in PEAK 16F877A. The CLCD is a typically interfaced with a PEAK 16F877A using a 4-bit or 8-bit parallel communication mode through the port B and port D, which is enabling the efficient data and command transfer. The PEAK 16F877A with a sufficient input-output pins and stable timing control using its timer makes it ideal for displaying messages, sensors, values, or system status on the LCD in embedded applications like washing machine interface. Tools used in this project are, first we use the MPLAB IDE, which is a free platform which is cross-platform integrated development environment which is used for programming PIG, DSP, AVR, and SM microcontrollers. It provides a powerful features like code editing, debugging, simulation, and project management, all within a user-friendly interface. Exit compiler, which is a compiler specifically for 8-bit PIC and AVR microcontrollers. It is optimized for high performance and supports integration with MPLAB IDE for a sufficient efficient code development and debugging. PICSIMLAB. PICSIMLAB is a graphical simulator designed for the simulating PIC microcontrollers using the circuits and interfacing them with a real virtual hardware. It allows users to test the debugging embedded applications without physical hardware, which supports the integration with the compilers like the MPLAB XC8. So let's see the project implementation using these tools, that is PICSIMLAB, MPLAB and XC8 compiler. So see how our washing machine works using this. Conclusion. Through this internship, I was able to understand the importance of C programming in embedded C, understand various types of embedded systems, and got to know where each type of embedded system should be used. Use various tools to implement a simulation of washing machine using the microcontroller PIC16F877E. Thank and special thanks to the Emertxe for this great opportunity.